Let me see if I wrote them here and that summary. Okay. So I'm going to put it in reflections with respect to the x-axis, and the same thing with respect to the y-axis. Okay. So let's see transformations. That's reflections. Reflections with respect to the x-axis, and reflection with respect to the y-axis, or good. So f of x, I'm going to pick again, let's say the square root of x. F of x with the square root of negative x. I'm changing x. So when I change x from positive x to negative x, from positive x to negative x, when I'm changing y, I'm changing y from positive y to negative y, or from negative y to positive y. So when I change x, it's always a reflection with respect to the y-axis. So reflection, WRT, this is how lazy people write with respect to the y-axis. So let's see how this looks like. Here is our graph of the square root of x. But this is x, and this is negative x. So here's the graph of the square root of negative x. So that's the reason why this was a reflection with respect to the y-axis. Now, because remember, we change x. Now, the reflection with respect to the x-axis for the same function will be this. F of x equals the square root of x, and f of x equals the opposite of the square root of x. Positive x, positive y, negative y. So in this case, it's outside. So I perform this, I get the y value, and then I multiply by negative 1. So the square root of x is this, but the opposite of the square root of x is this. And this is a reflection with respect to the x-axis. Reflection, WRT, with respect to the x-axis. So when we change x into negative x, or negative x into x, but here when we change y into negative y, y, and negative y, or negative y into y. So let's illustrate with another function. Do you want to pick, or I will? Okay, I will illustrate with x squared. You'll see what happens with x squared. F of x equals negative x everything squared, and f of x equals negative x squared. So I will graph x squared. This is the graph of x squared. But this graph tells me to reflect with respect to the y-axis. But since the function is already even, this is identical with negative x squared. So these two are identical. This one is a different story because I have y and now I want negative y. Y, now I want negative y. So negative x squared will be a totally different situation. Negative x squared. Reflection with respect to the x-axis. Now I would like to combine all of the above, all transformations we had. Here it is. F of x equals the absolute value of x minus 2, with minus in front, sorry, and plus 2. I have to list the transformations in the order of operations. So, number 1, can anyone tell us which base function did I use for this?
Absolute value.
Of course, no. The base function is absolute value of x. Correct. Step number 2. If you're asked to evaluate this function for, let's say, x equals 3, which operation will you perform first?
3 minus 2?
Exactly. So this is my first step. So that's my x minus 2. Perfect. Then which operation will you perform next? So now you have this number. It's there. We determine it. We apply the absolute value. Which operation do I apply next? After I find this, what is the next step in order of operations? What do I need to do next?
Distribute that negative?
I will not distribute because it's the absolute value, but I have to multiply by negative 1. And then what is the final step that you need to perform? So this is number 2, and this is number 3. So I have negative x minus 2 plus 3. We decompose this function to the bare bones. So this function is a complicated function based on the absolute value of x. The first transformation on the absolute value of x is x minus 2. Where does the graph go? Left, right, up or down, or reflect? Where does it go? It takes this graph where?
Does it go down to?
Careful, I'm changing x. It's not outside. I'm changing x to x minus 2. It's okay, you are just seeing this now.
Is it right?
To the right 2. Perfect. Now, this transformation is on this function. What did we do to this function to get this one? It's outside.
reflect
with respect to
the y-axis.
the x. I'm not changing x into negative x. I'm changing y into negative y. Very good. Reflect with respect to the x-axis. Final transformation is on this function. I have this function plus 3. Where does this go?
Up 3.
Up 3. Absolutely. Thank you. I need a sip of water. Up 3. Perfect. Excellent. So now let's graph them in this particular order. We have to keep the order as is. Now you can say, do I have to put them on the same coordinate system? No, you don't have to. You can spread them because now, there are 4 functions in there. So let's see what happens. This is the absolute value of x. We know it's the v function. We want to move right 2. Okay, fine. Right 2. I'm going to use a different color. Here's right 2. If it's not a good color, let me know. Parallel. So this is the absolute value of x minus 2. Then you told me to reflect this function with respect to the x-axis. Excellent. I'm reflecting it. I reflected it. Maybe this is not a good color. Let me use green. Okay. Then you said, move this up 3. Fine. 1, 2, 3. I move this up 3. This is final. F of x equals negative the absolute value of x minus 2 plus 3. So first, shift to the right 2. Then we reflected it with respect to the x-axis. And then we went up 3. Before we look at stretching vertically and horizontally, let's look at some examples. Let's choose to solidify I am probably logged out of that. We'll see in a moment. Look at that, I'm not logged out. Believe it or not. That's wonderful. Oh, access denied, of course, I'm logged out. Okay, give me 1 second. Let's see if I can get back in. Yes, I'm back. Almost there. Transformations. I'm opening it. Okay. Believe it or not, I'm back. Okay. So let's take a look. Suppose that the graph of a function g is known. The graph of y equals g of x plus 2 will be obtained by a, so we have g of x, and we have now g of x plus 2. Is it a vertical or is it a horizontal shift?
Would it be vertical because it's on the outside?
Exactly. Absolutely. Perfect. Shift of the graph of g at a distance. So is it up or is it down? A distance of 2.
Up.
Of course. Very good. Absolutely. Okay, moving on. Suppose that the graph of a function f is known, then the graph of y equals f of x minus 2 may be obtained by what?
Horizontal.
Yes, because we are changing x to x minus 2. Very good. Now the question is, are we going to the left or we're going to the right?
To the right.
Of course, because we are looking for the x-intercept. Absolutely. Select the correct choice that completes the sentence below. The graph of y equals the opposite of the f of x. Is the graph of f of x reflected about the
X-axis.
about the x-axis, about the x-axis, absolutely, from the positive y to the negative y values, of course. Great job. Okay, suppose that the graph of a function f is known. Then the graph of y equals f of negative x may be obtained by a reflection about the
Y.
yes, because it's the y to negative, it's the x to negative x. Perfect. Very good. The graph of y, we didn't talk about this yet. This is my last transformation. We didn't talk about this yet. Yes, I want to talk about this. Use transformations of f of x equals x squared to graph the following function. G of x equals x squared minus 2. What type of shift is this?
C.
It's down 2. So it's the graph of f of x equals x squared should be shifted to 2 units down. Absolutely perfect. Okay, it will ask you to graph this now, which is the same thing. Yes, it's okay. Use transformations of the absolute value function to graph g of x equals the absolute value of x minus 5. What type of transformation is this?
Vertical shift.
Vertical shift. Excellent. It is a vertical shift. So I just want to make sure it doesn't say anything about 5. It's a vertical shift, horizontal reflection. Perfect, yes. Good. Use transformations of the absolute value. Now it's asking you to graph it and then shift it down 5 units. Let's see 9. We use transformations of the cube root function, the cube root of x, to graph the function, the cube root of x plus 6. What transformation is this on the cube root of x?
Six units to the left, so it would be B.
6 units to the left. The graph of this should be shifted 6 units to the left. Absolutely true. Good. Use transformations of the cube root function to graph the function. Okay, so this is the same thing. It's going on forever. Okay, so we have to choose and graph it. Okay. Use transformations of y equals the square root of x to graph the following function, and the function is the square root of x minus 7. Where will the graph go?
It will shift to the right.
It will shift to the right. Should be shifted 7 units to the right. Perfect. And then it will ask you to graph it. We did not do this yet. Yes. So use transformations of the graph of f of x equals x squared to determine the graph of the given function. So let's look at this function. Negative quantity x minus 3 squared. Can anyone tell us which one is the first transformation that we have to look at? We had a similar example. Let me write this down for you. So we have h of x equals the opposite of x minus 3 squared. Which one will be the first transformation? And first of all, which one is the basic function? Which function was used here?
X minus 3.
So it was x squared.
X squared.
Yes, the function that was used was x squared. Now, which is the first transformation? In order of operations, as if, just imagine as if you are evaluating the function.
X minus 3.
Exactly. That's the first transformation. Awesome. And now what type of transformation is this on x squared?
Moving to the right.
Right 3. Very good. And finally, the last transformation is on this function, the opposite of the y value. Because the sign does not touch x. The sign is outside.
Oh, it will reflect horizontally.
Reflect the y value to the negative y value. So reflect with respect to the x-axis. Very good. So let's graph it. We graph x squared first. We've graphed it so many times right now. And so tonight we remember this forever. This is x squared. Then you told me to shift this 3 to the right. Okay, fine. 3 to the right. And then you told me to multiply all these y values by -1. And that's what I'm going to do. I'm going to multiply all of them by -1. So the opposite of x minus 3 squared. So let's see what the problem is asking. Which part? Remember we said write 3 and reflect it with respect to the x-axis. Which one?
D.
Exactly D. You meant D or you said B?
D is in dog.
Perfect. Excellent. Good. 13. Good. What do we do here? What are the transformations now? And which one is the basic function that was used for this one?
The square root.
Yes. Indeed, for this one, the square root was used. The next transformation in order of operations. Which function should I write as the next one? As if you evaluate the function for 4. Which operation will you perform first? Which one? The square root of x plus 5, right? And then finally, what will be the last one? Anyone? It's the square root of x plus 5 plus 6, correct? So what does this do to this? This to this, what does it do? Anyone with me? It's a left shift of 5. So yes, left 5, correct. What does this do to this?
Vertical 6.
Up 6, excellent,
Up 6.
perfect, good. So then let's select left 5, up 6.
Is it B?
Yes, perfect. Okay. What transformations are needed in order to obtain the graph of h of x from the graph of f of x? Select all that apply. So can anyone dissect this? What is the first transformation on the absolute value of x? What transformation is this on the absolute value of x? The absolute value of x minus 1.
Would it be horizontal shift?
Of, correct, which direction? Yes.
To the left.
It's x minus 1. The x-intercept is at 1.
To the right.
To the right 1, perfect. So right shift, so horizontal shift of, in this case, 1, right 1. And then
Up 2.
careful, it's minus 2. I know it's confusing, but minus 2, when we apply it to y, is down 2. So here we are changing x, and we are moving to the right 1, but y is what it is, up with positive and down with negative. So we will have a horizontal shift, and we will have a vertical shift. There is nothing else involved. There is no reflection. We haven't even talked about vertical stretching or shrinking. We haven't even talked about the last one, this horizontal and vertical stretching or shrinking, and there is no reflection. This is it. So first of all, right 1, down 2. We didn't talk about this yet. We didn't talk about this yet. I think it's slightly different. I want to explain this situation here. Okay, yes. Can anyone identify the transformations on the absolute value of x? Which one is the first one? Which one is the first one? Please try.
Would the first one be the absolute value of x minus 4? So
Exactly. Which is?
Horizontal.
Which direction?
To the right.
Excellent. So that's a horizontal shift. Perfect. What will be the next step? In order of operations.
A vertical shift up.
We can't. We have to, you are ahead of me. That's okay. But we have to, in order of operations, we have to multiply by -1 first before we add 5. So when we multiply outside, is it a reflection with respect to the x-axis or with respect to the y-axis? It's outside. We're changing y. We're changing y from positive y to negative y. One more time. When I change x to negative x, and when I change y to negative y. Again, x to negative x, and when I change y to negative y. Okay? So we identify the horizontal shift. Now there is a minus outside. It does not touch x. So it is a reflection, but with respect to the y-axis or with respect to or about the x-axis or about the y-axis.
Y.
The y will change, it will be negative x, but it's outside. So we are changing the positive y values to negative y values from the top to the bottom. So that's reflection about the x-axis. And then what else? Now Hunter said up 5, correct. So this is a vertical shift. So we have a horizontal shift with x minus 5. We have a reflection about the x-axis because it's positive y to negative y. And then we go with a vertical shift up of 5. We haven't discussed this one because of the 3 outside. I'll explain right now. We haven't discussed this. I just wanted to see what is there. Yes, and we're going to be able to determine that in a minute. And I still need to see the last one. Pretty similar. Yeah. Okay, perfect. Okay, finally, vertical, horizontal, stretching, shrinking. This is a little bit cumbersome. It's the last one, and it's a little bit, let me stop this.